So our third and final way to solve a system of equations is by elimination. There used to be a dating show called Elimination. I think it was on MTV. There was a girl, she went out with like three guys, and then she would eliminate one and go out with another one, eliminate that guy. Yeah, it's called elimination. Yeah, and that's what we're going to do, but, not with people. So here we go. How do you eliminate? Number one, first thing you need to do is you need to make sure that your system is set up in standard form. Okay? You want your system set up in standard form. If it's not set up in standard form, you need to try and get it into standard form as best you can. So standard form, remember, is ax plus by equals c. Okay? So elimination has to be set up both of your lines. Number two, what you're going to do here is you want to get one variable from one equation to be the opposite of the other equation. Okay, so we're looking for opposites. Opposites, for example, negative 2x and positive 2x. 10y and negative 10y. Now, the reason why is because if you add them up, they eliminate. They cancel each other out. They're opposites of each other. Okay? All right, so that's our second step. Third step is then you are going to add the two lines together. If you have opposites, you're going to add the two lines together. Some people don't like to get opposites. They like to get the same and subtract. I've done that before, but I realized that, you know what? You're really bad at subtraction. Yes, even my ham kids, they just had to do 10 minus negative 10, or 0 minus negative 10, and yeah, anyways. And then finally, number 4, make sure that you put your answer in a point form. You're finding x and y, okay? All right, so hopefully you remember how to do this. Hopefully this kind of comes back to you, like riding a bike. Number 1, here we go. 4x plus 2y equals 9, and negative 4x plus 3y equals 16. So let's talk about the system for a minute. If I had to graph that, I'd be pretty mad. Like, I don't want to graph that. That looks terrible. I can't do the intercept method, okay? If I wanted to solve by substitution, that'd be tough. I'd end up with fractions, and I'd have to solve for one of the variables. So what we're going to do, instead of those two things, we're solving by elimination. So we're in standard form. We also have opposites already. So guess what we're going to do? We're going to go to step 3, and we're going to add these equations together. Okay? And if they're set up in standard form, then all you have to do is add the columns going down. So 4x and negative 4x, those eliminate, hence the word elimination. 2y plus 3y is 5y. And 9 plus 16 is 25. So y equals 5. Okay? Don't forget, step 4, though, says we got to go back now and plug it in. And you got to plug it into either one. Okay? Usually you want to choose the one that is, the nicer numbers. I'm going to go to equation 1 here. I'm going to plug 5 in for y so that I get 4x plus 10 equals 9. Okay, 5 goes in for y, giving me 10 there. Subtract 10 to the other side. So then you get 4x equals negative 1. So x is negative 1/4. That would have been really terrible to graph, huh? I would have never thought that was negative 1/4 5 is the answer. Really bad. Okay, pretty easy, right? This is an Algebra 1 basic problem. This is like the first type of problem you get when you learn this in Algebra 1. Now let's go to a little harder problem where it's not set up yet with opposites. I'm going to show you how to set up opposites. So here we go. Suppose that you have negative 2x plus 5y equals negative 2, and x minus 3y equals positive 3. Okay. So if you take a look at the two x's here, I have negative 2 and positive 1. Those are not opposites. And I have positive 5 and negative 3. Those are not opposites. But all I need to do is multiply one of my equations by a number, and then I will have opposites. So if I take, for example, this second equation here, and I multiply the whole thing by 2, I'm not changing it. It's still the same line. As long as I multiply all the terms by 2, it's not changing at all. But what I'm going to get is a positive 2x, and look, then I can eliminate. Yeah. Okay, so let's do that. Rewrite the first equation down, and then take the second equation and multiply everybody by 2. So I'm just changing the second equation, and don't forget to multiply all 3 terms by 2. First term, second term, third term. Okay, and now we're ready. We're ready to eliminate. We have opposites. Let's go ahead and add these together. So my x's will eliminate. Drugs are ready. It's just in time. It's Friday. Negative y equals 4. Divide by negative 1. So y equals negative 4. Okay, a lot of people might stop there on accident. Don't be one of those people. Keep going. Negative 4 is the y value. Now let's plug that back in, and you can plug it into any of the equations up here. They're all going to work. I would probably plug it into this one right here before I multiplied and made it big numbers. I would go x plus 12 equals 3. So then x would be negative 9. I solved that okay, right? Yeah. Negative 9. I went to this one right here. This one. You can go to any of these. Doesn't matter. So I went to this one because the numbers were the smallest. Just kind of chose that. All right. Let's try now number 3. This next one. So the first one I didn't have to multiply. The second one I had to multiply one equation. What do you think I'm going to have to do on the next one? I'm going to have to multiply both of them. Yeah. All right, so let's try one of those. Here we go. I've got 2x plus 7y equals 4, and 3x plus 5y equals negative 5. All right. Now, if I were given a choice out of the 3 methods to solve this, I'd still choose elimination, even though it's going to take me a while. Because it's not good to graph this one. It's not good to substitute. This is really just elimination, but it's going to take a little bit of time. So if you notice, you can choose to eliminate the x's or the y's. It's really up to you. I think I would choose the x's because 2 and 3 are just smaller numbers than 7 and 5. So this is what I'm going to do. I'm going to take the entire first row, and I'm going to multiply it by 3. When I do that, I will get a 6 here. Okay? So then I'm going to take the entire second row, and what am I going to multiply that by? I think I would do negative 2, just to get opposites and add. You could do positive 2 and then subtract, but remember what I said about subtraction? You don't want to do it. Okay? Now, did I just pull those numbers out of the hat? No. I looked at 2 and 3, and I said, oh, well, they both go into 6. So what if I got this to be 6 and that to be negative 6? That's what I did. So now let's go ahead and let's multiply them. So I get 6x plus 21y equals 12. And here we get negative 6x minus 10y equals 10. This is the same system. It's just everything's been multiplied, but it's the same exact stuff. And now let's add it up. Earlier I added wrong, and I was like, oh no, what's happening? See, when you add, you get, what do we get here? 11y equals 22. That's kind of when you go sweet. I think I got it right, Because you know that's divisible, and I'm telling you there's probably going to be nice numbers. All right, so I get y equals 22. So y is 22, which means, no, see? Nope, see, it never happened. See that? Y equals 2. I caught myself right before you did, so that doesn't count as a mistake. No, I've made a lot today. I think it's lack of sleep. Okay, so there you go, 2. Now, take that 2 and plug it in. You can plug it into any equation you want. Any of the originals, any of the green ones here, you can just plug it in. I would probably go to the tippy top first one, and I would plug it in there. So 2x plus 14 equals 4. 2 goes in for y. 2 substitutes in for y. 2x plus 14. Can you solve that in your head now? Are you getting that good at math? Yeah?
Yeah.
I know, right?
Maybe like -5?
Yes, that's great. If you can't, that's okay. Subtract 14 to the other side. Divide by 2. X is -5. So there you go. Those two lines intersected in that point. -5, 2. Subtract 14 first. Divide by 2. Okay, I want to show you real quick, well, we have like 3 minutes left, a couple of special cases. Because as you noticed, the ones we did today, they all had a 1-point solution. But we know that there are 3 different things that can happen, right? You can get 1 point, all the points, or no points. So what do those look like? I'll show you. Here's what they look like. Last 2, and they're super quick, okay? Negative 3x plus y equals -5, and 3x minus y equals +5. So let's say we're going about our own business, we're getting to the problems, and we find a problem like this, and it says solve by elimination. You're like, okay, cool, I'll solve by elimination. Ooh, it's already set up as opposites here. But what happens is it's opposites there and there. Oh, and there, yeah. So what you get is 0 equals 0, which is true all the time, right? So this one would have infinite solutions. What happens is when you graph these 2 lines, they're the same exact line on a graph, okay? And when you solve it by elimination, you get a true statement, which means infinite solutions. Now, what does it look like to get no solutions? I'm going to do this one in red because bad. Here we go. 4x minus 6y equals 6, and negative 4x plus 6y equals 10. That's a 10. All right, so the book says solve using elimination. You go ahead, you have it all set up to solve, and what happens is those eliminate and those eliminate, leaving you as 0 on this side. But what does 0 equal? It equals 16. No, it doesn't. Not ever. So this is a false statement. This is very false. So there's nothing that would work. This would be no solution. What kind of lines are those? They are. I heard it. Who said it? Nice. You're kind of half listening and half doing your own thing. I like that. No solutions. Because you don't need me. No, you don't.